So, okay, so a family of graphs, right, is basically a group of graphs that have the same characteristics. So, for example, all parabolas are a family of graphs. All linear equations are a family of graphs, okay? The parent graph is basically the simplest graph in that family, okay? And then we do transformations on the graph to create other family members. So we're going to go through a couple of graphs. The first is a constant function. If you have a constant function, so for example, f of x is equal to 3, or y is equal to -2. The graph of this is just a horizontal line, okay? And it's called a constant function. So what would be the equation of this function here? Y equals what, do you think? 1, right? Y equals 1 because it passes through y equals 1. Yes. Okay, so any horizontal line is a constant function, and the equation is y equals whatever number it passes through. Then we have an identity function. It looks like f of x equals x. When you graph that, you get a line that looks like this, okay? Any of these diagonal lines, like a linear function, hang on. Any of these diagonal lines, like a linear function, right, are called identity functions. And now this could look, like this could have different steepness, or it could be facing the other way, whatever. Now, let's talk a little bit about domain and range. So, look at the first one. Domain is, if you look horizontally, over what space does this exist, or what space does this take up? Yeah, all real numbers, right? Let's put calculators away for the time being, please. So the domain here will be all real numbers. So again, the best way to write all real numbers is this. Some of you guys are having trouble with the R. It's really not that, don't overthink it. So just do, here, look up here to the right. Just do like 2 bars close to each other, like you would do like parallel lines. And then from the first one, just do an R, okay? Now, for the range, you have to go vertically, bottom up. Bottom up, you have to see over what space, what y values is there a graph. There's nothing here, nothing. There's a graph at y equals 1, and that's it. So we just say 1. And range and domain, if they're specific numbers, always go in curly brackets. Sunny.
I have 2 questions. One for the range, could you do y equals 1 or no?
You can do that.
And then secondly, that's a 0 slope, right?
Correct. Okay. Here, what will be the domain? So over horizontally, it's all real numbers. And the range too is all real numbers because it takes up, it exists everywhere bottom up. Okay. Next, we have an absolute value function that looks like this. Okay, the way to remember this is, absolute value, V, the graph looks like a V. Okay? All right? Now, what would the domain be for this? All real numbers. Now the range, you go bottom up. There's nothing here, nothing here. Graph starts at 0 and goes up greater than or equal to 0. So look up here for a minute. On the quiz, some people just said greater than or equal to 0. Not good enough. It has to be y is greater than or equal to 0. Okay? Here, this is a quadratic function, and it'll be a parabola. So anytime you have the square, you get a parabola. The domain here, too, is all real numbers, and the range is y is greater than or equal to 0. Okay. So today we're going to focus on graphing absolute value functions. So here we go. We're going to graph the parent function. The first one, we're going to do a table. But then after that, I'm going to show you a shortcut so you don't have to spend time on a table. Yes?
Can absolute value function be upside down?
Okay, let me teach absolute values and then I promise I will answer all your questions. Yeah.
Did you mean to pass the part of the bottom?
I kind of did, because we're going to talk about transformations. That's what this says. So we're going to see how like we can take the original function and then we can like displace it somewhere else. So we're going to see how we can graph this versus this. Okay? All right. Here, let's graph some absolute value functions. So first we're going to pick some values for x. Now, what values do you pick for x? Really, you can pick whatever values you want. You can pick 357.2, but that's not a very good choice, right? The best thing to do is to have a good representative sample. You want to pick some negatives, you want to pick some positives, and you want to pick the 0. So why don't we stick to -2, -1, 0, 1, 2. So I plug -2 in here. So the equation is y equals absolute value of x. It'll be absolute value of -2. We just get 2. Absolute value of -1. How much do we get?
1.
And absolute value of 0 is 0, and then a 1 and a 2. And this is why we had to do all those calculations by hand without a calculator in chapter 1. Do you see that? It wasn't because I was trying to like give you guys a hard time. So at -2, y is 2. At -1, y is 1. 0, 0. 1, 1, 2, 2. Now, with a ruler, if you're doing this on the homework, with a ruler, even I'm going to try to use a ruler here, you have to connect these points. It looks like it's worse when I use a ruler on the screen. Okay? All right. Yes.
Well, why didn't you make the 1 negative?
Here? This one?
Yeah.
Okay, because this will go in the absolute value. It'll be absolute value of 1, which will still be 1. Yeah? Okay, yes.
Oh no, we have to use a ruler.
Yes.
What if we don't have a ruler?
You can find one. Use a credit card
You can put
or the side of your calculator cover.
Oh.
You each have a calculator cover. Okay. Use your student ID card. Okay? All right. So notice this is just like y equals x, like y equals mx plus b. This is just y equals mx plus b. You can do the table every single time. It's like a foolproof way of doing it. However, there is a shortcut to do this. So remember how we said the absolute value graphs will look like a V. This corner here is called the vertex. Once you plot the vertex, so in this case, the vertex is at 0, 0. Once you plot the vertex, the rest you can just do like slope, rise over run. So take a look at the equation here. F of x equals absolute value of x. Do you see how there is a coefficient in front of the absolute value, and that's just a 1? Use that like your slope. So you say slope is 1 over 1. That means from that blue vertex, I go up 1 over 1, and then up 1 over 1, and I plot a point, and I can do my graph that way. Whoops. Okay? Does that make sense? All right, so now let's do a couple more. Okay, now translation. A translation is when the graph physically moves up, down, right, left. Okay? So when a constant is added to the parent function, so you get f of x plus k, the graph goes up k units. When it's subtracted, it goes down k units. So take a look at this one. The original function was f of x equals root x. Now I have a plus 2. On the outside, I have a plus 2. That means I move the graph vertically. I move it up 2 spaces. So where is the new vertex going to be? At 2. 0, 2. From there, what is the coefficient in front of the absolute value? 1 over 1. So I go up 1 over 1, up 1 over 1, and that's enough points, and I do my lines. Okay? Okay, let's do another one. F of x equals absolute value of x minus 3. Where does the minus 3 move the graph? Down 3. So now the new vertex will be down here. Where is the new vertex? 0, comma, negative 3. What's the slope going to be? 1 over 1. So I go up 1 over 1, up 1 over 1, boom, boom.
How do you get 0?
Because this point is x is 0, y is negative 3.
So it's always up 1 over 1?
Okay, you look here. You look here. Whatever number there is here. If there is nothing there, that's a 1. So if there was another number here, it would be that. Okay, now this is how we move it up and down. How do you move it horizontally? If there is a number added or subtracted inside. So when h is added, you go left. When it's subtracted, you go right. This is opposite to the sign, okay? Opposite to the sign. So take a look here. The minus 5 is inside the absolute value. It's inside with the x. That means it moves horizontally. But now, when it's inside, you have to move. When it's inside, you have to move in the opposite direction. So if it's negative 5, you go opposite to positive 5.
Because it's an absolute value.
No, just because it's inside with the x. Okay? If it was outside, you wouldn't. Absolute value, parentheses, it doesn't matter. So now, what is the slope for this? 1 over 1. So I go up 1 over 1, up 1 over 1. There. Okay?
So if it was positive, I would move to the left.
Correct. So now, this next one, where does the plus 3 move the graph? Left 3. Where does the minus 6 move the graph? Down 6. So I go left 3, down 6. So who can tell me what the vertex is? Yeah.
It's negative 3, comma, negative.
Correct. Slope is 1 over 1, so I go up 1 over 1, up 1 over 1. There. Okay, so from here, I go up 1 over 1, up 1 over 1. Okay. Now, what if there is a reflection? A reflection flips the graph over. So, when the parent function is multiplied by negative 1, there is a reflection in the x-axis. And that's all we're going to talk about right now. Okay? Okay, so take a look at this. There is a negative there. That negative means it's a reflection. It's flipped over, downward. Now, is the graph going to move anywhere here? Does it move left, right, up, down?
No.
It does not. So the vertex is here. But because there is a negative, slope is negative 1. So I go down 1 over 1, down 1 over 1, and it looks like this. Okay? Now, next one. Where does the plus 1 move the graph?
Negative 1.
Left. The negative is a what?
Reflection.
It's a reflection. So I go to the left one, and from there I go down 1 over 1, down 1 over 1. There.
I'm confused. Can you explain that one again?
This plus 1 moves the graph to the left 1. But there is a negative in front. That's the slope, negative 1. So I go down and over,
Okay.
and then
Like,
symmetrically
since we
there.
have a walk, like, you know,
Mm-hmm. Okay, next transformation is a dilation. A dilation, it either shrinks or enlarges the graph. So either makes it narrower or wider. Okay. When you multiply by a coefficient greater than 1, how do I undo this? Greater than 1, it's a vertical stretch. When you multiply by a coefficient between 0 and 1, it's a vertical compression. So take a look at here. You see that number 3 is greater than 1? This is a stretch. Well, you see how this number is 3? You know that 3 is greater than 1, so this is a stretch. Okay? So, what's the vertex going to be here? 0, 0. This time, slope is 3 over 1. So I'm going to go up 3 over 1, up 3 over 1. Boom, boom.
It just manages this.
Yes. So you see how this made it narrower. But now look, if I were to take one of these absolute values, and if I were to stretch it upward, you see how it would become narrower? That's why it's a vertical stretch. Now if I were to compress it, what would happen? It would become wider. Okay? So take a look at this one. Here, m is 1/2. Is that greater than 1? No, it's between 0 and 1, right? So it's a compression. So I'm at 0, 0. I go up 1 over 2, up 1 over 2, and then I draw my... You see how this one is so much wider, okay? So, on your test, I'm going to give you a graph, and I'm going to ask you to describe the transformation. And you have to use words to describe the transformation. So you have to say the graph moves up 4, down 3, reflection, vertical stretch, blah, blah, blah. Yes?
Do we have a word bank?
No. But you already know. By the way, is that your notebook? Right there?
Yeah.
Okay. All right. I thought it belonged to somebody named Math because that's all it said on top. Make sure you grab it. Okay. So look at this one. If you have f of x plus h, is this a horizontal or a vertical shift? Nope.
No, because it's a plus.
Right. It's inside. If it's inside connected to the x, it's horizontal. That's how I remember. If it's inside connected to the x, so this is going to be left h units.
Because whenever it's plus, you move
If
it
it's
out.
plus, you move that way. Okay?
Why'd
No.
you say?
We just did that. Look. Here.
H is for horizontal?
No. Okay. If you have x plus a number,
Yeah.
where does this 3 move it?
To the left.
To the left,
Left
3.
Yeah.
So if it's plus a number, it moves to the left by however that number is. Okay?
Oh, I get it.
Okay. So
Right H.
this one is right. This is connected, so it's right h units.
Oh,
Okay. What about the plus k?
Oh, that's the y intercept.
yeah.
Not y-intercept. It
Y
just moves
up 1.
up k units.
Okay.
What about the next one? Minus k.
Down
Down
K.
K.
Okay, if you have a negative out front, what is that?
Up. Down at the unit.
Reflection.
It's a reflection. Good. See, you don't need a word bank.
Oh, it's inverted.
This one, cross it out.
Y.
Huh? It's a reflection around the y-axis, but we're not going to do it right now.
Stretch.
This is a vertical stretch. This next one. So, how do we know? You have a number in front. And it's greater than 1. It's a vertical stretch. If that number in front is between 0 and 1, it's a vertical compression.
So anytime it includes less than 1, it's going to be a compression.
And then cross out the rest. Okay, so now take a look. F of x is equal to 1/2 x minus 3 plus 5. Let's describe the transformations. Okay? Okay, raise your hands. What's one transformation here? Vertical compression. Okay, that's the half. Okay, so let's think of another one. Izzy. Right 3 units. So this function in front, it's multiplied by a half because it's between 0 and 1. Compression. Okay, there's one more. What's the next one? Up 5 units. Yes. Not less than. No, not less than 0. So 3 is up 5 units. Okay, let me give you guys another one. See, it's not that bad. Okay. Okay. What's one transformation? What's one transfer? Let's think about this for a minute. Go ahead and raise your hands. What's one transformation? Okay, Sienna, you give me one.
Down 1.
Down 1 unit. Okay. Aiden, give me another one. Reflection. That negative is a reflection.
Wait, which negative?
The negative half.
The negative half. Correct. So what does the 1/2 do? What does the 1/2 do, Sunny? Vertical compression. Is there anything else?
How many max notes, like, is it possible to have? Could you have, like, does that make sense? We have 3, but
Yeah. You could have 1, 2, 3, 4. I guess we did 4. Okay? Something could move to the left. It could move down. It could have a vertical stretch. It could have a reflection. Okay? All right. So we're going to stop here today. Okay? I see you again when?
Friday, tomorrow morning.
Tomorrow morning.